All right, we're going to keep working with our lines today. We're going to be in section 3.5, and today we are going to be proving lines are parallel. So proving lines parallel means we're going to have some lines and we're going to prove that they're parallel. So let's go back to our little picture of two parallel lines. We remember this well, right? Here's our two parallel lines, and they're going to be cut by a transversal. We'll go around and we'll label our lines real quick. So angles I meant. So 1, 2, 3, 4, 5, 6, 7, 8, right? And we are going to mark these lines parallel. So now everybody knows they're parallel. And remember, when we see parallel lines, cut by a transversal, we know the following things that we're about to write down. We know corresponding angles are congruent. We know alternate interior angles are congruent. We know alternate exterior angles are also congruent. And we also know same side interior angles are supplementary. And we know that same side exterior angles are supplementary. Okay, so when we see this picture with these parallel lines, we know this, 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 and this. We know a lot of things about all the angles in that picture. Now, our question for today is, what about when we see lines cut by a transversal and we don't know they're parallel? So let's write that down. So what about when we see lines cut by a transversal and we don't know if they're parallel? So remember in our picture up here, we had our marks that told us the lines were parallel. So now we're going to redraw the same picture, right? We're going to have line R. We're going to have line S. So we can go ahead and mark R and S. And we're going to have a transversal, right? Cuts right through them. And we're going to label our pictures exactly the same. So 1, 2, 3, 4, 5, 6, 7, and 8. But what you will notice, or hopefully notice, R and S are not marked parallel. Okay, and since they're not marked parallel, you can't assume that they're parallel. So we're going to look at some pictures where the lines are not marked parallel. And the first one we're going to look at, and they're all going to look like this, so don't get too worried. We'll do very simple sketches. All right, so here's our first one. And we are going to mark this angle and this angle. So what we've marked here is two corresponding angles. Okay, so we're going to write down something today called the converse of the corresponding angles postulate. Exciting, right? So it's exactly the same as the corresponding angles postulate, except it's going to be the converse. So we're going to switch the hypothesis and the conclusion. So now, instead of saying if parallel lines are cut by a transversal, corresponding angles are congruent, we're going to say if corresponding angles are congruent, then the lines are parallel. Remember, we're going to start using our shorthand more. So if corresponding angles are congruent, then the lines are parallel. So when we look at this picture here and we see this, right? If we looked back up, right? Look back up at our drawing here. So the example that we're doing in this picture says if angle 1 is congruent to angle 5, that's what I've marked here. I marked angle 1 and angle 5. So if angle 1 is congruent to angle 5, then R is parallel to S. So the converse is used when we're trying to say the lines are parallel because of the angles. If we already knew the lines were parallel and we were going to say the angles are congruent, then we don't use the converse, we use the original postulate. So we're going to do an example of the other 4 now. So quick sketches. So we're going to do the converse of the alternate interior angles theorem. So the first thing I need is a little sketch of some alternate interior angles. All right, so that's going to be right here and right here. And this is the converse of our alternate interior angles theorem. Notice I'm trying to save you as much writing as I can. We're writing real simple. Okay, and this says if alternate interior angles are congruent, then the lines are parallel. All right, so our example that I marked right here is going back up to our picture, right? It's angle 3 and angle 6. So if angle 3 is congruent to angle 6, then R is parallel to S. All right, next one is alternate exterior angles. So we need a picture of that. So 2 lines, don't know if they're parallel, cut by a transversal, and we need our alternate exterior angles. So this is our converse of our alternate exterior angles theorem. Remember, converses are the opposites of the theorems. So the alternate exterior angles theorem says if 2 parallel lines are cut by a transversal, then alternate exterior angles are congruent. So our converse will say if alternate exterior angles are congruent, as in the picture to the left, then the lines are parallel. So again, example, back up to our picture that we're referencing. We marked angle 1 and angle 8. So if angle 1 is congruent to angle 8, then R is parallel to S. All right, 2 more. Now we'll do our same side angles. So we're going to draw a picture of same side interior angles. All right, a little bit different because they're not congruent, so we're just going to aim at them. So we're going to say this angle and this angle. All right, so this is going to be the converse of the same side interior angles theorem. And it says if same side interior angles are, now remember, these aren't congruent. These are supplementary. Then the lines are parallel. So if we look, that would be angle 3 and angle 5. So an example in a problem, if we saw the measure of angle 3 plus the measure of angle 5 equaled 180 degrees, then that would mean that R was parallel to S. All right, so last one, our same side exterior angles. So we'll draw a picture, 2 lines, transversal, and we're going to mark our same side exterior angles. So the converse of our same side exterior angles theorem says that if same side exterior angles are supplementary, then the lines are parallel. So again, in your work, you would see a picture, you would see a problem, and you would see angle 1, sorry, the measure of angle 1 plus the measure of angle 7 equaling 180 degrees. So you see that happen. You would conclude that the line R is parallel to the line S. And we can go back through our pictures and mark all these R and S if it helps you when you're studying. So RS, RS, and RS. All right, so those are the 5 converses of those theorems that you need to know, and now we need to know these converses as well. So have a great day.